Consider the following waves, and these waves are electromagnetic radiation. Which wave has a longer wavelength? Well, you don't need an explanation for that. It's wave A, right? Because it's just longer. That answer to that is wave A. Calculate the wavelength. We're given here a length of multiple wavelengths. Wavelength is crest to crest, or one point of one wave to the same point on the next wave. So there's 1, 2, 3, 4 waves. Just take that total distance as 1.6 times 10 to the negative 3 meters, and just divide that by 4. All right, let's take our, we don't need a calculator because you see 4 goes into 16 4 times. So let's turn that into 16 by moving that decimal over once. That means we're going to lower the exponent, and so it's going to be 4 times 10. Hold on. Let's get a sig figs here. 4.0 times 10 to the negative 4 meters. Wavelength of wave A. Did it ask us to calculate both? Calculate the wavelength. Let's just do it. So the wavelength for wave B, 1, 2, 3, 4, 5, 6, 7, 8. All right, well, there's twice as many waves. That distance is the same. If there's twice as many waves, the wavelength of wave B must be half as big, or twice as small. So it would be 2.0 times 10 to the negative 4 meters is the wavelength of wave B. All right, just in case they wanted us to do both, there it is. Which wave has a higher frequency? Speed of light is equal to wavelength times frequency. Frequency and wavelength are inversely related. Wavelength is inversely proportional to frequency. One goes up, the other one goes down. If wave A has a longer wavelength, then wave A has the lower frequency. So it's asking which one has higher frequency. That is going to be, oh man, I should have spaced these. How many questions are there in this part here? Is like 5-part question. Higher frequency is wave B because it has a shorter wavelength. So frequency. And larger photon energy. Well, we know that energy is directly proportional to frequency, right, by Planck's constant. That's also going to be wave B because it has the shorter wavelength, higher frequency. It's going to have higher energy. Calculate these values. What values? Frequency and energy? Is that what it's referring to? Calculate, I guess so. All right, let's do, okay. I think it just means wave B. We have the wavelength of wave B, so let's just use that. Let's do frequency first. Let's divide here this thing by wavelength, and we'll get frequency is equal to the speed of light over wavelength. Speed of light is given to you on your formula sheet as 2.998 times 10 to the 8 meters per second. And wavelength here we just solved. We just figured that out earlier. Is 2 times 10 to the negative 4 meters. 2.0 times 10 to the negative 4 meters. You know, this is not visible light. Meters cancels out. We're left with per second. That's the unit of frequency. Let's punch these numbers in. 2.998 times 10 to the 8 divided by 2 times 10 to the negative 4. All right, let's write this down. 2 significant figures, right? Because our original number had 2. 1.5 times 10 to the 12 hertz. Let's just write per second for now. Calculate these values, frequency, and then the energy. That's the frequency of, let me label this a little clearer. That's going to be the frequency of wave B. So now we can use this one here. Energy is equal to Planck's constant times frequency. That's going to be Planck's constant 6.626 times 10 to the negative 34 times the frequency is just right there. Guess we'll write it again. Planck's constant is joules seconds. Seconds cancel out. Left with joules. Go back to our calculator. That number is still there. Times Planck's constant 6.626 times 10 to the negative 34, 9.9 joules. Maybe like infrared. Calculate these. Which wave has a greater velocity? All right. Well, they're both the same because they're both electromagnetic. So this is the same. C. What type of electromagnetic radiation does each wave represent? A and B both have wavelengths of times 10 to the -4 meters. So that is going to be right here between the microwave and infrared range, microwave and infrared.